Now you can speak, Akansha, about the homework which I have given you. Okay, just reply me.
So an example of unbalanced force is that if a box is kept on a table and we are applying force to it so that it can move, and if it is moving, that means it is unbalanced force because the frictional force is not in that quantity as compared to the force applied by us. So that is why the box is moving. And an example of balanced force is a apple hanging on the tree, because the gravity which is the gravitational force which is applied by the earth is of the same as applied by the tree's limbs. So that in this case the apple is not falling from the tree.
Very good, very good, very good. So she told me two examples.
That it is the force exerted by the tree system or the force of reaction.
Please switch off your mic. Yeah, now say, Arpita.
Sir, I have a question. Sir, according to Akanksha, there is a force exerted by the stems of the trees, but it is force of reaction or the force exerted by the stems.
Repeat again your question, because there are some unwanted noise which are coming from your side. Okay.
Okay.
Yeah, repeat once more. Arpita,
Yes, sir, 1 minute.
yeah, repeat your question. Hurry up, I'm not having time. Okay, let's move on to Aditya.
Sir,
Yeah.
so my question is that it is the force exerted by the stems or the force of reaction.
If force is,
Sir, according to Akanksha said that force of gravity and the force of stems. And sir, I have a question. Sir, it is the force of reaction or it is the force of the force exerted by the stems of the trees?
I'm telling you. So in that case, what is happening? For example, there is one apple which are being hanged like this. Okay, this is an apple. So here is the limb by which it has been attached by the stem. Okay. So while it is hanging free. Okay, it is hanging free. So at the same time, because of some mass of this apple, it may be of 100 gram, it may be of 50 gram apple. Okay. So this mass, I told you that it will act what? It will act in downward direction, and it is equals to mass into acceleration to gravity. This is the weight. This is the weight of an apple. Okay. And weight is what? If you want to define weight, then it is the force with which a body has been attracted towards the earth's surface. Okay. So weight is nothing but weight is what? Force or pull. Okay. So this is the downward force you can see towards the earth's surface. Okay. At the same time, this limb of the apple has been joined with a fixed stem or with a fixed branch of an apple tree. So to balance or to keep that apple on that branch only, there may be some force which may be acting against this force, which may be acting in the upward direction, so that the apple may not fall. Okay, so that the apple may not fall down. So this force will be acted along this limb. Okay, through this limb only the force is acting in the upward direction, and the direction of the force will be like this. Okay, so this is the reaction force. This is the action force. Okay, apple is trying to go down, but this is the reaction force which is acting through the limb through which it is joined. It has been joined to a stem. Okay, this reaction force is acting in the upside direction. Okay, is it clear?
Yes, sir.
So
Sir, I tell why.
yeah, now let it be. Okay, I know that most of the people have done their homework. So let's start our new topic. Okay, so let's start our new topic for today's lecture. So you people can switch off your mic. Okay. Yeah. So last time what we talked about, I again want to give you the brief description about our previous lecture. Last time we have talked about the types of or the classification of the forces in terms of balanced and unbalanced force. Okay, and I've shown you many examples which have been given in your NCERT book. I need everyone who is sitting there watching my video that they should open up their NCERT book so that I may try to give the examples and try to show the example, and it will be very clear to you people, if you are having your book in front of you. So from the book only I'll be giving you the example so that you people may feel easy to understand everything. Okay. So now just open up your book and go to page number 119 or 199, 116. Okay. So today what we'll be talking about? Today we'll be talking about first law of motion. Okay. Today we'll be talking about first law of motion. Let us go. Okay, there are total 3 laws of motion. According to Newton was the only person. Okay, Galileo was someone. One was Galileo, and the other was Newton. Okay, Galileo was the first person who gave something or who gave some description about the moving object. And secondly, there was a person or scientist named as Newton who described each and every motion which is there happening in the entire universe. Okay, according to his laws. Okay, he gave total 3 laws. Okay, he gave total 3 laws. Newton gave total 3 laws. Today we will be studying about the Newton's first law, and hopefully we will be completing the second law also. Okay, but and in the third law, what we have talked about action and reaction forces. Yesterday also, what I told you, I've given you one example of action reaction force. Okay, according to Newton's third law, and today also, on behalf of this apple which is on that branch, I've tried to show the practical example of the third law. So first law, what is first law? First law talks about the property. Okay, it's talk about the property of a moving object. Okay, earlier, according to the concept of Galileo, Galileo was also a scientist. He told that he took one example. Okay, he took one example. He took 2 wedges. You can see there in your book. In your book, you can see the practical which has been printed there. In the book, you can see that there are 2 wedges like this. Okay, and from one wedge, he is dropping down the ball. Okay, he is having one ball, and he is dropping this ball from the topmost point of this wedge. And 2 wedges are similar. That they have similar height, they have similar inclination. Okay, they have similar inclination and they have similar height. According to Galileo's explanation, what he tried to explain, he told that if we drop this ball from the uppermost part of the wedge, and if we are having 2 wedges, okay, we have joined these 2 wedges. So if we are dropping this ball with a certain height, then the ball, after rolling down, will reach the bottom, and after reaching the bottom, it will try to move on to the other wedge, and it will go to the same height, okay, from where it has been dropped. For example, if it has been dropped from 2 meters, then on the other side also it will go to 2 meters. Okay, but he was not knowing knowing the concept of frictional force. He was not knowing the concept of the laws of the nature. He was not knowing the laws of the nature. Newton told him, or Newton replaced his theory by giving some laws, and he told that no, Galileo, your theory is totally irrelevant. It is not too right, or it's not applicable in every case. Now I am giving you some of the laws which are well proven, which are well verified, and according to me, this ball, if it has been dropped from 2 meter height, and it will never reach back to the same height on the other wedge after coming down with some velocity, because there may be some frictional force also, which may be on the surface of the wedge on which the ball is rolling. On the other hand, if this wedge is kept on the surface of the earth, if I am performing this experiment on the earth, then earth may also have some gravity, that it will always try to attract this ball towards the center in the downward direction. So whatever will be the speed while coming down, the same speed will not be here. Okay, the same speed will not be at this position. The same speed will not be at this position. The same speed will be not at this position. Okay, so that means it is not necessary that if I am dropping it from 2 meter height, it will reach to the other wedge to that same height. Okay, it will always lie somewhere downward. That it may travel some distance to the other wedge, but it may not travel that distance which this rolling ball will take while it comes from here to the downward direction. Okay, for example, if it is traveling a distance of 5 meters on this wedge while coming down, then it may be traveling some distance of 4 meters or 3 meters on the other wedge, which is of similar height. Okay, so he told that, and the reason why it has traveled less as compared to this, because of some frictional force which this ball can experience while going upside on the other wedge, and it may be due to the downward force which will act continuously towards the surface of the earth. And on behalf of these observations, on behalf of these forces which were acting on the ball, he gave 3 laws. In first law, he told, according to our first heading, that is the first law of Newton, he told that the object will remain in the state of motion, or will remain in the state of rest until or unless any force may act on it. Okay, अगर कोई बॉडी है वो हमेशा क्या रहेगी, अपने मोशन में अगर बनी है तो वो मोशन ही में रहेगी जब तक कि क्या हो, उस पर कोई अलग से फोर्स कोई अप्लाई ना करे। और अगर एक बॉडी है अगर रखी हुई है कहीं पे तो वो रेस्ट ही पे रहेगी जब तक कि हम उस पे क्या करें, उसको हम उठा करके एक जगह से दूसरी जगह ना रखें, यानी कि जब तक हम उस पे कोई फोर्स ना रखें। ठीक है, तो यहाँ पे भी उन्होंने कंक्लूड किया, here also he concluded that since there will be a change in velocity, there may be some force which a ball may experience when it comes here at the bottom in between these two points, and that force will be due to the surface also, which may obstruct, and that force may be due to which this gravitation also, that it will always try to pull down that ball. It will never allow that ball to reach this height of 2 meters. Okay, so just because of this force, just because of the force of gravity, okay, the two forces will act, gravity and frictional force. Frictional force is what? Frictional force will be in this direction. If ball will try to move in the up direction, in the upper side, then the frictional force always act opposite to that. Always. Okay. If ball is coming down from here, that means the ball is moving in this direction. So the frictional force will be in the opposite direction. Okay, so frictional, what is the property of frictional force? Frictional force always acts in opposite direction of motion. Okay, frictional force will always act opposite in the direction of motion. Okay, according to the concept of Newton. Okay, and it actually works in the same manner. So he told just because of this frictional force and just because of the gravitational force, those are the opposing force, the ball will never reach to that height. And as a result, there will be some change in the velocity also. Okay, the ball may be having some velocity when it would have just reached the surface. There may be some velocity. But at the moment or after the moment when it tries to move on the upper side direction on the other wedge, in that case the velocity will continuously decrease just because of the downward force of gravity and just because of the frictional force which will be acting. Okay, हमेशा क्या होगा, उसके velocity में क्या होगा, change. तो हम एक conclusion और दे सकते हैं. One conclusion can also be given from here, as we have seen in the case of circular motion. You people might be remembering that there was a continuous change in the direction in case of circular motion. Okay, in case of circular motion there was continuous change in the direction of velocity. Similarly, from here what we can conclude, force results in the change in what? Change in direction. Okay, change in direction and velocity of a moving of a body. Or better to say moving. Okay, since this gravitational force is acting, since this frictional force is acting, so there will be a change in the velocity when this ball will go in the upside direction. Okay, so this was all about the experiment which was clarified by Newton's after the Galileo's experiment. Okay, according to the Galileo, he mentioned nothing. He mentioned his motion without the application of any force. But Newton gave some description about forces also. And he told that there are always some force which will be responsible behind the motion of such type of thing. Okay, now is there any doubt? So you people can ask. Yeah, answer. Answer, any doubt?
No,
Sir.
sir.
Sir,
Bolo?
sir, according to Newton, if any force acts upon an object, then it could not reach the same distance as covered it by first time. So,
Yeah.
sir, if no force acts upon it, then will it reach?
So if no force acts upon it, then
If no force acts upon them, then will it reach to that distance?
it will reach. Okay. When no force will act on that, then it will continuously move. It will never stop. It will go to till infinite. It will move on to the other side. It may move beyond. It may go to the other side also. Okay. For example, if we started rolling a ball like this on the surface, and this surface is smooth, that means there is no friction. And I have given initially the velocity of 2 meters per second. Okay, let us assume. And this is the frictionless. Okay, this is frictionless surface. Frictionless surface. So in such surface, if I am initially given this much of velocity, and since there is no opposing force like this, there is no opposing force of friction. So the body will continuously move and it will reach till infinite. It has no end of its end in this case. Okay. Yeah, anyone else? else? No one?
No, sir. No, sir.
Okay.
No, sir.
According to Newton's first law, he told, again I am explaining here, he told that if a body is moving with a constant speed, then and in a specific direction, then it will continue its motion in the same direction with the same speed until or unless any force may act on it. Okay? The speed will not change. The direction will not change. So I'm writing down here. You people can note down in your copy also. In the same way, he also told the concept of rest. In concept of rest also, the body will remain be at the rest position until or unless any force may apply on it and it may change its position or it may give some velocity. Okay, so suppose that I kept this mobile on this table, so it will be there only until or unless I may pick this mobile, it will be there until or unless someone may touch this mobile, so it will in that case it will not change its position. Okay, after the touching only, after giving some force only to this mobile which has been kept in front of me, it will move. That means its state has been changed. Earlier the mobile is supposed to be in the state of rest, but now after applying the force or after applying the pull by my hand, it has changed the state. Okay, now it is supposed to be moving since my hand is moving. Okay, so my hand is applying some force on it, and as a result the velocity, it has some velocity now, you can see. Okay, earlier it was having no velocity. So this concept was first visualized by Newton, and he told that the body will remain be in the state of motion with same speed, and in same direction until any force may act on it. Okay, until any unbalanced force may act on it and may change its speed and direction. Okay, its speed and direction. Okay, so this is Newton's first law. As you can see that it has been written there, the body will remain be in the state of motion with same speed and in same direction it will move until any unbalanced force may act on it and may change its speeds and direction. As I told you in that explanation also, in the former case which we have discussed, that there is some application of force while a ball is trying to go upstairs, and just because of the application of the downward force due to gravity, there is a change in the speed and the direction. Okay, now the speed of the ball has been slowed and the direction has also been changed just by the application of the force. Okay, so that in that Newton applies this law to explain that theory, which earlier has been explained by Galileo, and that theory which was explained by Galileo do not contain these laws, do not contain these physical laws as explained by the Newton. So on this law, on behalf of this law only, he gave his explanation a valid proof. Okay. So this is the Newton's first law. Okay. Similarly, Newton's first law can be explained for the case of rest also. Okay, you can see there are many examples which are given there in your book. That in that case, what we can say, that body will remain at the position of rest or remain at the state of rest until or unless any unbalanced force may act on it and may change its position, speed, and direction. Okay, same thing can be applied for the case of rest also. So now what is the final conclusion? Okay, what is the final conclusion? This this law this law is also known as the law of inertia. Okay, this law is also known as the law of inertia. Now the question is that what is this inertia? Can anyone explain me that what is this inertia? What Newton was trying to tell by using this word inertia in his law? Anyone? Why I'm saying this? That this is the law.
Yes, sir.
Yeah.
The inertia is a tendency which approaches the force, the motion of which tendency is the state of change in the rest or a uniform motion.
Yeah. Very good. So, how will you define that inertia? One can say that it is a tendency, or one can say that it is also a property of a body. Okay, it's a property. If you are going from one place to another, it's your property that you are going. Okay, it's your characteristic. Similarly, it's your tendency. Without that tendency of moving, you cannot move your body from one place to another. Similarly, that is the tendency of the body. Inertia is what? Inertia is the tendency of the body. You can see, okay, it has been written there in your book also. Where it is? On page number 116. 116, you can see on the right hand side, it has been written like this. In other words, all the object resist a change in a state of motion. It has been written there in bold letters. So in that only, it has been written the tendency of undisturbed object. Okay, the tendency of undisturbed object to stay at rest or to keep moving with same velocity. If a person is moving with same velocity, then it's his tendency. If a person is sitting on a chair, so that is his tendency to sit at rest position. Okay, similarly for a body, here the definition of inertia has been defined. Okay, so what it says, that it is the tendency of undisturbed object. Inertia is what? Tendency or property of undisturbed object to remain. If the object is undisturbed, that means it is at rest position. That's why I'm using that, to remain at rest. Or again, the tendency of an object to be in motion. Okay, or the tendency of an object object moving with some velocity. Some speed is known as inertia. Okay, so inertia can be with respect to rest, and inertia can be with respect to motion also. Okay, there is no doubt to anyone regarding Newton's first law.
No,
But
sir.
after that also, in our next lecture, we will be discussing about some more examples of Newton's first law. Okay, we will be discussing about the inertia term. That when an object is moving, then it is in the state of motion. So in that case, it is
No, sir.
in the inertia of motion or in the inertia of rest. Okay, so if the object is at one place, it has been kept at one place. That means the position with respect to time is not changing. So in that case, the object is supposed to be at the inertia of rest. So the inertia in that case is the tendency of the body, and the tendency of the body is just to be at rest. So this simply
Rest.
about this term inertia. Okay, it is very simple. So
Okay,
let's
sir.
Okay, sir.
the next lecture. And if there will be
Thank
any
you, sir.
I have given you my number, you can message me and you can take the snap of that question or the concept which you are not getting. Then I'll be replying you there also. Okay. Otherwise,
Okay, sir.
Okay, sir.
Okay.
okay. Thank
Thank you,
Thank
sir.
you, sir.